Hi everyone, in this video I want to talk to you about how we know if a system is linear or nonlinear. First, what is a linear system? A system is linear when its mathematical model is linear, otherwise it has to be nonlinear. So think of this as a straight line on a graph in terms of our input to our outputs. Why is this important to us in control systems though? To apply a Laplace transform on our model, we need to ensure that the mathematical model is linear first. We will deal with nonlinear models in future videos. Just for now, know that you cannot use a Laplace transform when the model is not linear. That is very important. So, how do we determine if a model is linear or nonlinear? To determine this, the model must satisfy what is called the superposition principle, which has two tests, the additivity test and the homogeneity test. If the model fails either one of these tests, then it does not satisfy the superposition principle and we do not have a linear mathematical model. Therefore, the Laplace transform cannot be used. The additivity model states that an input of a plus b into our function must equal to the separate input functions added together. The homogeneity test states that a scalar value times our input must be the same as if the scalar was outside of the function. If you're at all like me, this was extremely confusing, so let's go through a few examples to aid your understanding. What if we had our mathematical model equal to a? Well, plugging that in, we have the function f evaluated at a plus b, and since the model is simply returning our input back to us, we have a plus b as an answer. Well, now we need to separate a and b and apply them to our function separately. And as they are still just returning the input of the function, we can see that this model does pass the additivity test. Let's move on to the homogeneity test. So, as you can see here, whether we evaluate our function with the scalar inside or outside of our function, it doesn't matter, the same answer is achieved. Therefore, this function is indeed linear as it passes both the homogeneity and additivity tests. Let's do another example. What if our function is now a squared? Do you think this will pass the superposition principle test? Let's test and find out. So, for our additivity testing, we still have a plus b inside the brackets, but we need to square them. And using FOIL, we get the following answer, which is not the same as the function evaluated at a squared plus the function evaluated at b squared. Therefore, just because the additivity test fails, we know that this model is no longer linear. However, let's just test for the homogeneity so you can still better understand how this is performed. We write the following, and as you can see here, when we have our scalar times a squared, it is not the same as if we take the scalar outside the function brackets as the scalar is no longer squared. Therefore, this function also fails the homogeneity test. And because a squared is not linear, we could not take the Laplace transform of it. I hope this aided your understanding of why we test for linear systems, how we do it, and why it is done. Thank you for checking out this video. If you enjoyed, please like and subscribe to support the channel. However, if you have any comments, questions, or concerns about the information I provided in this video, please leave a comment down below and I will do my best to address your concerns.